Saxon, Advanced Mathematics. Laura, this is a video for you with the 2 questions you asked me about. Lesson 99, problem 13 is a log problem. Now, I told you, when you told me that you're not good at log problems, I told you that that was a very difficult conclusion for me to accept. And I'm going to keep fighting for your comfort zone around logs. Whenever you face a log problem, this is the first place I always want you to start. Identify the basic structure. We know that this is the base, and this is the number, and this is the exponent or the log. I don't like to say log because that's a new word that confuses the issue. I like to just remember that it's the exponent. And if you ever need to remember what even does that, where do these definitions come from, just remember this. Log 10 of 1,000 equals 3, right? 3 is the exponent that you put on the base of 10 to get 1,000. That will help you come up with these. Once you identify these 3 pieces, you see, oh, this is just a basic log equation. There's nothing fancy or special about this. I mean, this is a little weird, but that's not going to hurt us. So what we're going to do is rewrite our basic one, just like we can rewrite this as an exponential equation, right? We take the word log right out of it. What we just did here, we're going to do the very same thing here. All right, so I'm going to follow that pattern. We take the base, 2. We put the exponent on it, 2, equals the number, and that's the number. Oh, that looks really weird, doesn't it? But I recognize if I just wrote this the other way, if I just flipped the 2 sides around, I'd have this again, wouldn't I? Because it's a log in a log. That's what's cute about these problems. So I'm going to rewrite it just so it looks super familiar to you. And I'm going to just simplify this 2 squared. That's 4. And so we have now another basic log equation. That's the base. That's the number. And that is the exponent that goes on it, okay, that goes on the base. So now I can see, I'll do it in this format again, exponential equation. This is a log equation. This is an exponential equation. This one's got the word log in it. This one doesn't. We took that number that we called the log and we turned it into an exponent. That's why this is called exponential and this is called log. Okay. So we're going to take this and do the same thing that we did here. We're going to take a log equation and we're going to turn it into an exponential equation. And let me just write this. I trust you're writing all this down. If you can keep this puffy cloud of knowledge business in your head, you're going to go a long, long way in understanding log problems because a lot of them are just variations on this. Okay, so now we're saying 2 to the 4th equals, what's our number, x? Oh, that's really easy now, right? That's our final answer. Let me know if this makes sense to you. Text me right now. Pause the video. Hit your texts. And tell me either this makes sense or no, I still hate logs as much as ever. They're disgusting. Because I want you to like them. You're so broad in your command of these topics that I hate. I mean, you can't be equally smart at everything. Although sometimes you make it look that way. But you know what I'm saying. It would be really nice for you to end your high school math career with confidence in this issue because it will come up in your future and I want you to face it with a smile or at least a quiet wellspring of confidence. Okay, that is that log problem. This one is the identity problem. And I remember you had a specific question on this, but it's not in my nature to be able to just jump into the middle of the problem. I have to work all the way through it, even though I know you understand this part. And what we're trying to get to is 1 plus 1/2 sine of 2x. Okay, so this is our target. This is what we're getting to. This, I think you figured out, is a difference of 2 cubes. So we factor this according to the difference of 2 cubes, which is just a formula that we know. I think I gave that to you earlier. Let me know if you don't remember. Well, I'm pretty sure you do know how to do this because you told me that wasn't the sticking point. So difference of 2 cubes. That's what we're doing here, and I'm going to factor that. It's a long factoring, isn't it? But that's just the difference of 2 cubes, and then we'll put it back over its denominator. Cosine x minus sine of x, and we see those happily cancel, and we're left with this. So I'm just going to rewrite the whole thing. And I think this is the part that messed you up. Those two pieces put together is a Pythagorean identity. I'm just going to write Pythag. And I'll write it out. Remember, cosine squared x plus sine squared x equals 1. That's where we make the change and get the one that you were curious about. So now we have 1 plus cosine x sine of x. Okay. Now, this is the part of the problem that I was a little perplexed by, because to factor this, we need the product identities that I think for the first time we saw in lesson 100. And yet this is a homework problem for 99. So I'm a little bit gobsmacked because I don't understand how you're supposed to know how to factor this in lesson 99. It must have slipped through somewhere. But I see factoring this as a development that would only come from the product identities that we had in lesson 100. So I'm confused about the sequence of this, but let's remember how to develop this. We need to take the sum and the difference identities for sine, and we're going to add them together. Okay, so these we know from a ways back, right? These are the sum and difference identities. And to develop the product identity, we add them. These two cancel. We get sine of a plus b plus sine of a minus b equals this, 2 sine a cosine a. Then we divide by 2 slash multiply 1/2, same difference. And we get that this whole thing, I don't want to rewrite it, this equals, oops, this should be sine A cosine B because it's these two, right? This equals the product identity for sine A cosine B. That, without the 2's, is what I wrote there. Okay, so this is the identity, the product identity, but in our case, the letters match. We don't have A and B. We don't have different identities. They're both x's. So let's rewrite this with x's so that it's sine of x, cosine of x. That would be 1/2 times. This would be, let's just write this. This would be x plus x, and this would be x minus x. So x minus x is 0. So this part of the identity is going to drop away, and we're going to have sine, and we could write it as x plus x, but we can also just write it as sine of 2x. That is that, right? So this is all just the way that we develop this identity. Again, that's a product identity that we did in lesson 100. So now we can write 1, this is the 1, plus, and now this equals this, I just wrote those in the opposite order, 1/2 sine of 2x, and that is exactly what our target is. Yay, I always feel very satisfied just writing over that. Okay, so I hope this part makes sense to you. That's really the part, again, I'm confused because this is lesson 99, but we learned how to do this in lesson 100. So what's up with that? But hopefully I answered your question, which is way back here about the Pythagorean identity, those two pieces together after we factored the difference of 2 cubes. Then we had those 2 pieces, we put them together per the Pythagorean identity and got a magical 1. All right. Thank you, Laura. Let me know how this one went too. Talk to you soon. Bye.